The next question is, among the molecules O2, KO2, H2O2, F2O2 and BaO2, the pair that have the most similar oxygen-oxygen bond length is. Alright, we know that the bond order is inversely proportional to the bond length, right? So in O2, the bond order is 2. There is a double bond between O and O. In KO2, the anion, actually this is potassium superoxide, it is O2 minus and its bond order is 1.5. H2O2 has a single bond, it's a covalent molecule, contains a peroxide linkage, so its bond order is 1. F2O2 is also, it contains single bonds, its bond order is 1. And BaO2 is barium peroxide, O2 2 minus, its bond order is also 1. Now you see there are 3 molecules with 1 bond order, but in the options if you check, they have matched O2 with H2O2, of course not possible, O2 has 2, so this is ruled out. KO2 and H2O2, this has 1.5, this has 1, ruled out. O2 and BaO2, again ruled out. So now we are left with KO2 and F2O2. Ideally in this case also KO2 has 1.5 and F2O2 has 1. So just like we ruled out option B, we should also rule out option D. But in case of F2O2, due to difference of electronegativity, due to presence of electronegative element F, if you apply Bend's rule says that an orbital bonded to an electronegative atom will have increased p character. So in this in O2F2, in the OF bond there will be increase in the p character. So by default there is decrease in the p character or decrease in the p character in the OO bond, or you can say increase in the S character in the OO bond from both the side, which means the O single bond O will have higher S character than in a normal peroxide like H2O2 or BaO2. Because of that, because of the increase in the percentage S character, the bond length would decrease. As we know that the bond length decreases with increase in the percentage S character. So although this contains a O single bond O, but this O single bond O does not have 1 bond order. Its bond order will be more than 1. So it is very close to 1.5. So these are the 2 ions which will have the closest bond length. So it's a very good question. In D option, although first compound is a superoxide and the second is containing O single bond O, but because of presence of fluorine, there is increased S character in the O single bond O. Because of that, its bond length would decrease. So it would be close to superoxide. So that is our correct answer for this question.